Hi, this is Jeremy with Math Boot Camps, and I'm going to go through 4 examples of how you can use the laws of exponents to simplify expressions. In this first example, I'm actually going to do something a little bit different than I usually would to illustrate a point. Notice how everything inside the parentheses is multiplied. Now, I know you may notice there's 2 x's and we could combine those, and usually we would, but right now I just want you to take a look at the fact that we have a 3 times x to the 4th times y squared times x cubed, and all of that's squared. That's totally different than if there was, say, a plus or a minus in there, if we were adding or subtracting something. Since these are all multiplied, and it'd be the same if they were divided, I can distribute that squared. So this step you normally wouldn't write, but I'm writing it so you can see what I mean. Notice how the squared goes on absolutely everything. Mentally, this is what you should be doing when you see something like that, an exponent on the outside of a large expression where that expression is multiplied. Again, this doesn't work for addition or subtraction. Now I can go through and say, okay, 3 squared is 9. Laws of exponents tell me if I have a power to a power, I multiply. So 4 times 2 gives me x to the 8th. 2 times 2 gives me the 4th power for y. And 3 times 2 gives me the 6th power for x. Now I can say, well, I have 2 things with x here in them. Let me go ahead and combine those. Since these are multiplied, that means that I should add the exponents. 8 plus 6 is 14. And I can't combine x and y, they're different bases, and I can't combine the 9 in there, so this is it, I'm done. I could have combined the x's in the original expression before I distributed that 2, the power 2, and that would have given me the exact same thing, but I wanted to distribute first to show you. So typically I would have simplified first. But notice you get the same answer either way. Okay, let's look at something with division since we've seen something with multiplication. This also has multiplication in it too, though. Take a look at the numerator. This numerator is to the entire numerator is to the 3rd power. So you may have the urge to cancel these y's, the y on the top and the y on the bottom, but you can't yet because the y that you would cancel on the numerator is within parentheses there to a power. So my first step is going to be to distribute that 3. Now I'm going to actually show you 2 methods here, but the first step will be the same for both of them. So 4 times 3 is 12, and that y in the top is really a y to the 1, so 1 times 3 is 3. And notice I didn't change anything in the denominator. Now I can directly use the laws of exponents, and this is what's different between this method and the method I'll show you in a minute. I have x to the 12th and an x cubed. That's numerator denominator. So I would say, okay, that means I should subtract exponents. So we have x to the 12 minus 3, and then I have a y cubed and a y to the 1 power. That y by itself is to the 1 power. So it's y3 minus 1, and I have what? X to the 9th, y squared. Notice that I only combine things with the same base, so I didn't try to combine the x's and the y's. So that's why it's 12 minus 3 and 3 minus 1. I'm going to show you another method that starts out exactly the same. And really, this method is actually identical. It's just a different way of thinking about it, and in fact, I tend to use this more. I could say, well, look, x to the 12th is really x times x times x times x 12 times. And x cubed is x times x times x. Why don't I just cancel 3 of those x's? If I cancel 3 of the x's in the numerator, I'm left with x to the 9th. If I cancel 3 x's in x cubed, I'm left with 1. Okay, same thing with the y's. Y cubed is y times y times y. I cancel that with one of the y's. There's only one of them down the denominator. I'm left with 1 down here and y squared up here. Get the exact same answer. In the end, when you subtract the exponents, this is what you're actually doing, but this is a more direct method of seeing that. So you'll actually see most of the time people will not write down a subtraction step with the exponents. They'll do something like this, but both methods are correct, and they'll both give you the right answer. Negative exponents seem to throw people off. If I have x to the minus 3 by itself, that would be 1 over x cubed. But when you have an x to the minus 3 mixed up with other stuff, there's actually a bit of a shortcut you can do, and that's what this says right here. So notice that I have x to the minus 3 in the top, the numerator, and y to the minus 1 in the top, the numerator. So I can make those positive by moving them to the bottom of the fraction, to the denominator. What I'm really doing is saying x to the minus 3 is 1 over x cubed, and then multiplying that back in. but I don't really have to worry about the reasoning behind this. Is kind of a shortcut. And then y to the minus 1, bring that down to the bottom of the fraction. It's now y to the positive 1, and you don't have to write a positive 1 exponent. Okay, as before, I have a couple of x's multiplied, so I add their exponents. Nothing else can be combined, so I'm done. What if I had instead a negative on the outside of everything? Now, in the first example, I mentioned that you could distribute a power across division as well. This time, though, I'm going to do like I did before and simplify within the parentheses first, because usually that's going to be faster. So I could do the basic rule and say this is x to the 1, x squared, subtract 1 minus 2, I get minus 1 power. Or I could cancel. I say, okay, I'm going to cancel that x on top with one of the x's on bottom, and I'm left with just an x on the bottom in the denominator. And then I still have just my y in the numerator. All of this is the minus 2 power, so now I can distribute that minus 2 power. And since it's a negative exponent, it will be positive when I move it to the other part of the fraction. So x to the minus 2 moves to the top, y to the minus 2 moves to the bottom. I get x squared over y squared. Again, there is another way to do this. There's a shortcut here, but this shortcut I think just makes things more confusing, so I chose not to use it. So again, you can distribute exponents over multiplication and division, but not addition or subtraction. And if you can simplify within the parentheses first, that's probably your best bet. It's going to be quicker, but either way would work. And again, last point, for the division, when you have an x over x squared, for example, you can look at it as canceling factors or directly subtract like the rules of exponents tell you.